an experiment involving electricity. We're going to measure the current in a wire, we're going to measure the voltage across it, and that's going to enable us to calculate the resistance of that particular piece of wire. We're then going to alter the lengths of that piece of wire and see what happens to the resistance. In order to measure the current, we'll need an ammeter placed in series in the circuit, and to measure the voltage, we'll need a voltmeter connected across the wire. We'll obviously also need a power supply to ensure that the electricity flows constantly through the wire. Okay, in a moment I'm actually going to show you the experiment set up. I'm going to collect several sets of results and then I'm going to show you those results. You will need to do an evaluation from the data that you see. Okay, Year 10. Now, what you can see in front of you on the screen is the setup of the experiment. You've got the power pack, which has a lead coming from it into an ammeter. The current comes out of the ammeter and goes to one end, the far end of the wire. The electricity can flow along the wire through a lead back to the power pack. We also have this second meter, a voltmeter, across the circuit. At the moment, the wire is placed, the second crocodile clip is placed 60 centimetres from the first one. Okay, and I can take the current reading of 0.2 of an amp, and I can take the voltage reading of 1 volt. And I'm going to record that length, those two readings, then I'm going to move the crocodile clip here to the 80 centimetre mark, the 100 centimetre mark, the 120, and so on. Now the next thing you're going to see is that data collected. Okay, so I'm going to collect all the current and voltage readings at the different lengths of the wire. I'm going to maintain the same wire. I'm going to keep the voltage fixed on the power pack. I'm going to try and ensure that all the values are kept the same. Okay, so the next thing you see will be the results. Thank you. Taking that reading of 60 centimetres, you can see length of wire in centimetres, you can see current in amps, so that was 0.2, and the voltage, I said was 1, in fact it's 1.1. Emphasise that point, that's not very clear. Okay, now, Mr. Brown is going to move the crocodile clip along, so the length of wire we're testing now is 80 centimetres. And Mr. Brown? So, you should be thinking, is this being done fairly? Is it being done accurately? Okay, and the readings we have are
0.2 amps again, and 1.2 volts.
Okay, now we're going to move along to 100 centimetres.
And the results are again 0.2 amps and 1.2 volts.
Okay, 120.
Result is 0.1 amp and 1.2 volts.
Now just say there that something happened, the wires we were using weren't long enough to actually get along to 120, so we had to use additional wires, next to crocodile clips. Will that or won't that have an effect? Something you're going to have to think about. Whilst we're carrying on with this, I'll just explain to you as well, while Mr. Brown is moving the crocodile clip, that I will give you the equation in a moment that will enable you to use these current and voltage readings to calculate the resistance at the various lengths. Okay, I believe we're ready for 140. So
0.1 amp again and 1.2 volts.
160 centimetres.
0.1 amp and 1.3 volts.
Okay, so we've got all of those readings. I'm now going to show you how to turn a current and voltage reading into a value of resistance. Okay, so get rid of this. Obviously not the best way to do that. Okay, now resistance which is measured in ohms can be calculated by dividing the voltage in volts by the current in amps. So, we can now take those readings for different lengths and we can calculate the resistance of all those different lengths. Okay, now it's up to you to evaluate that experiment. Okay, so all the best and think, did we do it fairly? Did we keep all the factors the same that we needed to keep the same? Did we only alter the one variable that we went to? Okay, did we do it accurately? Did we read the decimal places in it? Did we repeat the experiment? Okay? So there's lots of questions you now need to ask yourself about the little bit of film you've just seen. Okay? So, all the best. Get on with it.